Today I'm gonna talk about how to solve the inequality. Before I solve the following examples, I would like to recall some basic properties for the inequalities. Okay, so let's take a look. The first one, if A less than B, we let both sides add C or subtract C, okay, then the sign of inequality should be the same. Okay, so if here is less than, here should be less than. If it's greater than, here should be greater than. Okay, doesn't change the sign of inequality. Now let's take a look the rule number 2 and number 3. If A is greater than B and C is positive, then if we let both sides multiply C, then the sign of inequality will be the same. Okay. Similarly, if A is greater than B, C is positive, then we let both sides divided by C. Okay, then the sign of inequality should be the same. So for example, here is greater than, here should be greater than. If here is less than, here should be less than. Okay, less than. What does that mean? That means if we multiply or divide by a positive number, the sign of inequality should be the same. Okay, should be the same. Now let's take a look the property 4 and 5. So if A is greater than B, now the C is less than 0. Okay, less than 0. If we let both sides multiply C, then we need switch the sign of inequality to opposite one. So for example, here is greater than, that means should be less than. If it's less than, here should be greater than. Similarly, if A is greater than B, if C is negative, okay, is negative, then we let both sides divided by C, then the sign of inequality will change to opposite one. That means if here is greater than, here should be less than. If here is less than, here should be greater than. Okay, what does that mean? That means if we multiply or divide by a negative number, then the sign of inequality will change to opposite one. Okay, opposite one. So that's the rules of inequalities. Now let's take a look the following examples. So for the first example, we're gonna follow the rule. Here we have a constant, -9. Okay, that means if we want to remove it, how to remove it? We're gonna add 9 for both sides. Okay, and 3x minus 9 will cancel out, 9. We're gonna get 3x equals 21. Right? 21. We don't need to care about the sign because we do the addition or subtraction. The sign of inequality will not change. Okay? We just follow the rule number 1. Now, here we have coefficient 3. Right? We wanted to simplify it 3x divided by 3, 21 divided by 3 for both sides. Okay, so here we know the 3 is positive, right? So if we divide by a positive number, we will not change the sign. We'll keep the sign the same. So if here is greater than, so here should be greater than. We just follow the rule number 3. Okay, rule number 3, and we can simplify it. X greater than 7. Okay, that's the solution. If we write this guy as set notation, that means we can write down like that. Now, if we wanted to write as interval notation, how to write it? Because here we don't have equal sign, so that means we should use round bracket from 7 to infinity. And how to graph it? We can draw the x-axis, for example. So 2, 4, 6, 8, 10. Okay, so 7 should be here, and we use the round bracket because we don't have equal sign, right? So we're gonna use round bracket, and this part gonna be the answer. Okay, answer. Now let's take a look the second one. For the second one, also we have the constant on the left hand side. We want to remove it, so we're gonna subtract 18 for both sides. Okay, for both sides, and then we cancel out. Then we're gonna get negative 2x equals negative 8. Okay, again I want to mention it. If we do the subtraction or addition, we'll keep the sign the same, so we don't need to worry about it, the sign. So the only thing we need to be careful when we do the multiplication or division, okay, especially for the negative number. Okay, here we have negative 2. That means we need to divide by negative 2 for both sides. Okay, for both sides. And we can tell here's a negative. That is a negative number. That means we're going to change the sign of inequality to the opposite sign. That should be greater than or equal to, because here is less than or equal to. Okay, so that means we follow the rule number 5. Okay, rule number 5, we divide by a negative number, and we have x equals 4. Negative 8, negative cancel out. 8 divided by 2 is 4. So we can write down as set notation gonna be x greater than or equal to 4, and of course we can write down the interval notation. That should be square bracket. Okay, square bracket, because we have equal sign. Now we can draw the graph. We have, for example, here's 2, 4, 6, 8. Okay, for the x-axis, and we have square bracket, and from here to here. Okay, so that's the answer. Now let's take a look the third example. For the third example, of course, we can see for both sides we have what? We have x variables. So we wanted to remove all the variables on the right hand side. Okay, remove phi x from the right hand side. How to remove it? Just subtract phi x for both sides. Okay, 3 plus phi x minus phi x, and then we can cancel out. Will be 2x minus 7 greater than or equal to 3. Now we wanted to remove the constant on the left hand side. Shall be 2x minus 7 plus 7 greater than or equal to plus 7. Okay, I want to emphasize here again, if we do the addition or subtraction, the sign of inequality will not change. So here, if I subtract phi x for both sides, it will not change the sign of inequality. Similarly, here, if I add 7 for both sides, I will not change the inequality. Okay, so we cancel out. 2x is greater than or equal to 10. Okay, and now we have 2x, 10. We need to be careful. We divide by 2 for both sides. Okay, because we divide by 2, that is positive. We will not change the sign of inequality. Okay, so if here is greater than or equal to, here should be greater than or equal to, and we should get x is greater than or equal to 5. Now we can write down as the set notation. If we can write down as set notation should be x greater than or equal to 5. Also, we can write down as interval notation. So we use square root because we have equal to. Okay, and then we can draw the graph. Here is 2, 4, 6, 8, and the 5 should be here, and we can draw the 5 here. It's over here. Okay, it's over here. Now let's take a look the last example. For the last example, we can do the distribution firstly because we have multiplication. Okay, now we have negative 2 times 4x plus negative 2 times negative 6. Okay, and negative 2 times 4x gonna be a negative 8x, and a negative 2 times negative 6 gonna be a 12. Okay, 12. Okay, here we have a constant 12 on the left hand side, so we're gonna subtract 12 for both sides, and we cancel out. Negative 8x is greater than negative 8. Okay, again I want to emphasize that. So if we do the subtraction or addition for both sides, here we do the addition for, right, we add 12, we subtract 12 for both sides. We don't change the sign. Okay, And here we just do the distribution. It's nothing to do with addition or subtraction for both sides, right? We just do the distribution for this term, so we are not changing the sign. Okay, now here we have negative 8x is greater than negative 8. We need divide by negative 8 for both sides. Because we divide by a negative number, that means we need to change the sign of inequality to the opposite one. So it should be a negative, or should be a less than. Okay, should be a less than. So here is x less than 1. And of course, we can write down as the set notation, x less than 1. Or we can write down as the interval notation. That should be less than, should be from negative infinity to 1. And be careful, we're going to use round bracket because here we don't have equal to. So now we can draw the graph. Okay, and again, since here we have the 1, right? 1 is not included, so we're gonna use round bracket to negative infinity. Okay, negative infinity. That's it.